and welcome to the Unreal Engine News and Community Spotlight. So first off, we're kicking off our Spring UE4 Jam next Thursday. That'll be May 10th, and it's going to run for 5 days through May 15th. We're really excited. We'll be announcing the theme at the end of next week's live stream. This is also the first time we're hosting it on itch.io, so there's some additional rules around that. As far as file size and just making sure you get your game uploaded to that site. So be sure to take a look over those ahead of the jam. But we also have a number of really fantastic sponsors. Falcon Northwest is on board. They have a really swanky laptop that will be raffling away to our finalists. Intel's giving away Octane SSDs to our finalists. We also have Houdini, Assembla, lots of great content that you all are eligible to win. So jump on that. We'd love to see what you all can make. Fusion has released a Mars 2030 editor in collaboration with NASA. So they're releasing a number of models and other assets, audio. They have an astronaut available and a waypoint system and over 40 square kilometers of terrain data that you can check out. So that's all available to download in the Epic Games Launcher. So go get it. This June, we'll be hosting our first Unreal Academy. That'll be taking place June 6th and 7th. We're going to be going over a number of features around Unreal Studio. There'll be keynotes, lectures, and it'll be a lot of details about Datasmith. We'll give you a glimpse at a roadmap. So make sure to go get registered for that and come visit us in Raleigh, North Carolina. Nick Pruis from Daedalic has written up a nice piece on dynamic third-person cameras. So they've written this piece. It's 6 ingredients for a dynamic third-person camera. And they're the creators of Deponia and Pillars of the Earth. So if you're interested in seeing how they've set up this system, it's allowing you to change a number of properties on your camera dynamically mid-game or mid-level. It's a really wonderful piece, so go check it out. There's a lot of wonderful details in there. Take a look. We also have a fantastic showcase on the Darwin project. So that's the Battle Royale game set in a really icy arena, and that's the Scavengers team, and I definitely recommend. There's just a lot of great content there, and you can see how they're working on stuff. And last but not least, we have our NVIDIA Edge program. We're always excited for all the amazing content you share with us, so huge congrats to Ma Chuang, Visual Lane, and Kieran, who worked on the LB work in progress working title. Submit your projects. We love seeing all this amazing content, and we get to send you 1080 Ti graphics cards for your hard work. So check out unrealengine.com/NVIDIA Edge for details on how to enter, and maybe we can send you a graphics card pretty soon. So on to our weekly Karma earners. These folks are answering tons of questions for their community on Answer Hub. So we just want to say thank you so much to Goncuss Mage, Shadow River, Every Nun, Thompson N13, Joseph, Yuki Ogano, Engelmana, T. Sumisaki, Nebula Games Inc., and Vahiva. Thank you, thank you, thank you. You guys rock my socks. So our first community spotlight this week is it's a fan art piece for The Last of Us. It's the apartment on Melbourne. So they've just done Sam's done a really fantastic job of setting up the scene and the lighting. He has a bit of a breakdown on his art station, and you can see all of his assets that he's created from scratch for this piece. So really great work, Sam. Our second community spotlight, this individual's it's their first time playing around in Sequencer, and they wanted to take a stab at a cinematic video in UE4, so they've titled it No Mercy. And so they're just getting familiar with Sequencer, and they've done this really wonderful cinematic put together with assets from Infinity Blade and Paragon, and just, it looks rad. And our third and final spotlight is a game called The Adventures of Gorm. So it's being created by Ronnie, who's an animator, and he wanted to try making his own game. So it's a sort of Ghosts and Goblins meets Rogue Legacy, very early in development, and he's learning as he goes. But it's off to a great start, and if you all want to go in and post on the forums, give him some feedback and tips and tricks for how he can keep working on it, please do so. All right, thank you for joining us for our news and community spotlight. Hey everybody, welcome to the Unreal Engine livestream. I'm your host Amanda Bott, and with me I have Jay Hosfeld, lead animator, and Tim Slager, other community manager.
Hey everybody, how's it going?
So I feel like it's been a while since we've seen you all. We've missed chatting with you at least. And yeah, you're going to follow up a little on what we worked on a few weeks ago.
We're doing round 2.
Should be a very animated stream.
Oh man, it's all downhill from here.
Oh, bad jokes for days.
Yeah, so if you haven't checked that one out, it'll be available soon for you all to watch and get up to speed to where we are currently. And then, yeah, feel free to take it away, Jay.
Great. Yeah, I will say if you haven't watched our first one, please, we will have it posted again, right?
Yes, yeah, we're in the middle of working on that, yep.
It'll be back. And please watch that first. And yeah, so for round 2, I basically just kind of want to jump off where we left off last time. Let me go ahead and play what we currently have. So when we left off, we had Shinbi running around. Let's get this full screen. Okay. So we had her running around, but right now if she runs right or backwards, she runs towards the camera. And typically we call this a forward-facing motion set. Today I just want to convert her over to a strafe motion set. And this is really good for shooters where you always want the character to be facing where they're looking. So let's just jump right in here. So the first thing I want to do to set this up is modify her blueprint, her character blueprint. And there's one big setting in here that will allow this. So open up her blueprint, click on the character movement, and we are going to look up orient. So right now the setting by default is orient rotation to movement. So basically this is going to always orient the character towards the direction they're moving. Let's turn that off. And let's see what happens now. Alright, so now if I run to the right or to the left, you'll see that she is still facing forward. And that's what we want. We currently don't have the animations plugged in to support it. And one other problem we're now going to encounter is if I spin the mouse around,
she's still going to stay.
It's all sorts of messed up. So there's one more setting we're going to do here. So let's open up her character blueprint again. And this time we're going to click on the Shinbi player character up at the top. And what you're going to look for now is a use controller rotation yaw. We want to use this, so let's turn it on. Let's hit compile. Now we'll play. And things will behave a little more like you expect. So now if you hit forward and move the mouse, she'll run in the direction. However, if I now hit left or right, she is still playing an incorrect animation.
That's how I run forward, inside to side.
Yeah. All right, so we're getting there. So the next thing we're going to want to change is some logic on the animation blueprint. Let's load this up. So right now we're querying a couple things from the pawn. You know, we're getting her speed, we're getting her yaw, her roll and pitch, but we're not getting direction. There's no way to feed direction so she knows, so that the animations know what direction to play. So let's go ahead and add that logic. So let's go to the event graph, and we'll go ahead and pull off the try get pawn owner. So if I zoom out, it's this guy right here. And let's pull off this. And the first thing we want to get is get base aim rotation. and that is just your base rotation of your the pawn. The next thing we want to go ahead and get is the vector, or we're going to want to go ahead and get the velocity. And then we are going to want to get the x vector off this. So you just type in, let's see, get, or no, we're going to do rotation from x vector. Rotation from x vector right here. And basically we want to get the delta between these two, and this is going to give us our direction. So I'm going to drag off this top guy, just type in delta, delta rotator, and let's go ahead and feed rotation from x vector into B. This is going to give us a rotation value. And let's go ahead and we're going to break this rotator into different axes. So go to break rotator, and that is going to give us our roll, pitch, and yaw. Now this yaw is what we want. This is ultimately going to be our direction. So you can drag off this, and you can click promote to variable. And let's go ahead and name this variable direction. And we need to feed this into that so it'll run. Okay, so now we're getting direction. And I want to show you guys, this is a really good debugging tool if you ever want to see if one of your variables are working. Is a good way to see this is you can drag off the output here and you can type print string. And this is super helpful, you know, for those just jumping into this. It lets you see what kind of data is coming out of this. So I'm going to type print string. And by default, it's going to go into the duration, but you want it to go into the end string. And that'll convert that to a string. And let's go ahead and turn off duration. We don't want that on. Okay. So now we're going to play. She's still going to be broken, but I want to show you guys what the direction is printing on the screen. So as you can see, when I run different directions, I'm actually getting these different values. So if I run to the right, I'm getting negative 90. If I run to the left, I'm getting 90. If I go backwards, I'm getting 180. So that's the kind of information I want to feed into my blend space. All right, so let's get back to the Anim blueprint. Now I noticed when I went to the left, it was giving me a positive 180, and when I was going to the right, it's giving me a negative. I want the opposite of that. So real fast, I'm going to delete the print string. I don't need it anymore.
Why would you want the opposite of that in this case?
Because I want my right just to be a positive 180.
Okay.
Just because when you set up a blend space, your min and max, typically your min is going to be a negative value, and your max, and
okay,
it puts
so
the minimum on the left, and it allows you to put a run right on the right side.
I got you.
So I'm going to go ahead and just put a multiplier here. Multiply float by float. And just to flip the values, I'm going to say -1. My math teacher is going to love me because
They said you'd never use math.
yeah, I use math. It's not complicated math, but we use it from time to time. Okay. All right, so now our direction values are pretty much what we want to be. So we have this concept of direction. Now I'm going to go to my anim graph, and we're finally going to see something happen with this. So let's go into our ground locomotion, and let's go into the run state. Right now the run state is playing a blend space, but it's not a directional blend space. It's playing essentially just a run and a lean blend space for my leans. We're going to go ahead and nuke this. So let's just get rid of this. Actually, I'm just going to go ahead and leave it here. I'm going to unhook it. For those of you at home experimenting with this, I meant to say this up front. It's okay to duplicate an Anim blueprint. If you have something really working well and now you want to experiment with new stuff, typically I just duplicate it. So I have my backup and I have a new one just to experiment on. I would recommend doing that with this if you're following along. But for now, I'm just going to leave this unhooked in case I want to hook it back. But let's go ahead and add a directional blend space in here. So in the Shinbi folder, you'll see a folder of blend spaces, and we actually have one set up for directional runs, and this is called the jog combat run, and it's only a one dimension speed. Let me get my, hold on, let me get my view back up. I drug it off the screen, and now I can't find it. Hold on.
Uh-oh.
Where are you?
Did you close it?
Oh.
Here we go. Here we go. All right. Sorry, guys. Okay, so we have a basically a directional. It's a one-dimension directional blend space. So right here in the center, if the value is at 0, she's running forward. As I go to 180, negative 180, or positive 180, she's running backwards. If I go to 90, she's going to be running to her right and to her left. And this is basically all her run directions blending together.
That's neat.
So let's go ahead, and this is fun working on one monitor. Usually we have two. It's like somewhat of a puzzle. All right, so let's drag this combat run into here. Let me maximize this so you guys can see. All right, so we have the jog combat blend space. Let's go ahead and feed it into our pose. But right now we have nothing informing the angle here. So let's go ahead and plug in that direction variable that we created. And compile, and then let's see if this works. Okay, so she's running. Yeah, here we go. Now she's running to her left. And you guys will see for a second she's kind of running forward. That's because our jog transitions do not have a blend space in them right now. But we do have her running backwards. And we have her running forward, right, and left. So lucky enough, we already had a combat jog blend space created. You guys all have this if you downloaded the Shinbi thing. But we need to create new blend spaces for the jog start and the jog stop. So let's go ahead and do that right now. So to do this, to create a new blend space, all you have to do is right-click anywhere in the panel and go to Animation, and let's make a blend space 1D.
What is a blend space 1D?
1D is you only have one axis.
So one direction?
Basically one variable controlling it.
Okay.
You could also have a two-dimensional blend space. So you could actually have, like, say, direction and speed on one blend space. In these cases, we're just going to have a one-dimensional blend space.
So if you're running faster and it's a different animation when you start running faster?
Exactly.
Gotcha.
Yeah, you could set up a 4 directions, but with speed, or maybe 4 directions and a slope. Or you could have, like, say it's damage. You want damage in your game. You want them to start limping. You could have your other axes be so basically, that's the benefit of having a two-dimensional. All right, so I'm going to create a new blend space. We want to click the correct skeleton, so that's going to be Shinbi skeleton. And let's call this, we'll call this jog start. Look at this. Let's see. Let's try this again. Jog start. Let's put BS at the end. All right, so we have one axis. Let's go ahead and call this axis direction. Now the minimum axis is going to be negative 180. The positive is going to be 180, and that gives you your whole 360 degree direction. And we'll go ahead and leave number of grids at 4. And over here, let's go ahead and fill up this blend space. So right here in the search assets, let's go ahead and just type in start. So as you see, we have a jog backward start, jog forward start, jog left start. So right at the 0, let's go ahead and drag and drop jog forward start. On the left, 90 at the 90 mark, we're going to do jog left start. Jog backward, we're actually going to put on 2 places. We're going to put it at negative 180, and let's go ahead and put jog backwards at positive 180. And we could do a jog right start at the positive 90 value. Let's go ahead and save this blend space. All right, and now let's go to her anim blueprint, and let's plug this new anim blend space in. And real fast, once I show you guys this, I'm going to go back to the blend spaces and show you guys a couple of things of how to keep them in sync. All right, so we created that jog start. And let's plug that in. Animations, blend space. Where did my other window
I think
go?
if
I
you
gotta.
hover over the U icon, you can show it.
What's that?
Like in the toolbar at the bottom. If you hover
Oh,
over,
there we go.
you can see your other window.
Oh,
Where is it?
it might be below the screen. Shift and...
Here, I'm going to close that.
There you go.
All right. All right, so we have our jog start blend space. Let's go ahead and open up the anim blueprint again. There we go. Got it back. So let's try this. All right. There we go. This is fun. Okay. Now let's plug in blend space.
People are learning how to operate with one monitor as well.
Yeah,
So this is more than just animation.
You guys just put a camera on my face and watch me be confused here. All right, so here we have jog start blend space. I'm going to drag and drop it over to, basically, if you guys didn't see it, on the anim graph, I'm in the locomotion, and I'm actually in the jog start state. And I'm going to replace just the jog, place the jog forward start with the jog start blend space.
Because that's going to incorporate.
Yeah, because now that's going to use the directional inputs. And so let's go ahead and get direction here. Sorry. And if you guys noticed last time we went over this, a lot of these animations were created for some proprietary Paragon code that we have not shipped out to you guys yet. We will get this later this year. So some of these animation assets were authored for that. So some of our start and stop animations have a whole lot more animation because we're using that data. The systems I'm showing you now don't need as much animation. So what we want to do is cut off a little bit of this jog start just so things feel like responsive. So last time we did this, I set the start position of the run at 0.32. We could do this with the blend space as well. I'm going to turn off loop. And let's just change the start position. Let's try something like 0.2.
Do you just iterate through that until you find something that feels right?
Yeah, that's a good question. Yes, we definitely iterate. If I were to do this properly, what I would do is rather than globally cut off 0.2 off a blend space, I would load each animation individually and trim frames off that.
But this is a way to do it without
This
all
is a
of
way.
that extra.
And, yeah, and I want to reiterate that I'm kind of going through some of these concepts. I want to show the concepts more than how to fine tune something precise because we'd be here all day. But there are lots of different ways to solve for these things. And so, yeah, you can go in and you really want to custom make your animations for the systems you're using. So really what you would want is to create these like starts that feel responsive just in the animation. And that way you're not doing some hacks on the blend space. I'm doing a little bit of a hack on the blend space here just because
We'll call it
we
a
have a lot of
unique
assets.
approach.
A unique approach.
Yeah.
Yeah. So let's try this out. Let's do this. So now we have our jog starts plugged in. And so now she is actually kicking off. If you see her running to the left, you can see her kind of lean into the run. If you see her start running backwards, she kind of leans into it first.
And she slides a little bit in the when she starts running backwards.
Mm-hmm.
Is that something within that blend space that you can kind of fix the timing on?
That is, and in fact, let's try something real fast with this. So any of you doing this at home, I highly recommend making duplicates of any animations you're going to tweak. So you have the originals there because we are going to release some more animation nodes. So I would please duplicate these animations. But right now, let's do the start backwards. So here we have the jog backward. And if I scrub through it, you'll see that she kind of has a pretty slow intro before she starts running backwards. And that's why we're seeing the foot sliding. For our blend space, it would be nice if we kind of had her starting around here because it would feel responsive. We'd get rid of the foot sliding.
Right.
What you can do is custom tweak these animations like I was talking about. So I'm going to slide to a frame where I feel like this would be a nice spot to enter the animation. And I'm going to go ahead. I'm going to go ahead.
When you start hitting backwards, you feel like that would be
right. I would prefer to kind of blend to this frame when I'm going backwards. And this is all tweakable stuff. This is why I suggest duplicating an animation. That way you can always go back and start over again. What I want to do here is if you right click on the frame you scrub to, you could actually delete some of the animation. So I want to go ahead and remove frames. Let's not cut off that much. Let's go to frame 6. And let's go ahead and remove frame 0 to frame 6. And basically I just trimmed off some of the animation. So now if I go back and play, let's do this. If I go back and play, there'll be less sliding when she goes backwards.
okay. Yeah.
Yeah.
So it feels like a more natural
Mm-hmm.
kind of step backwards.
Like I said, there's so many different ways to solve for this. That's definitely the way I'd recommend. It's just
Cut it from the animation itself.
get your animations perfect. If your animations aren't perfect, sometimes you're going to be tweaking a lot of stuff in the graphs to make it work, and that's just kind of a more expensive way ultimately. All right, so we have the backwards blend space. And let's go ahead and add the stop. Now the stop gets interesting, and I'll show you guys why. Let's go ahead and set up the stop animation just like we did with the start. Let's create our blend space real fast. So let's go, let me move this off screen. And let's go to the blend space folder. Let's create a new stop blend space. So we'll go to new animation, go to blend space 1D. We're going to click the Shinbi skeleton again, and this time we will call it jog stop blend space. Let's go ahead and open this up. And just like with the start, we want to go ahead and do a minimum axis of 180, positive 180. Call this direction. And let's go ahead. These are stops, right? So we'll go ahead and drag the jog forward stop into the middle. Jog left will be negative 90. Jog right will be positive 90. Jog backwards will be both positive 180 and negative 180. And this is an animation I highly recommend trimming. I would recommend making duplicates of and trimming. So let's go ahead and save this. Let's go back to the anim blueprint. We have the jog stop. So here we have the jog stop, just one direction animation playing. So let's go ahead and put in the blend space in. Okay. And so what do you think is going to happen here? Do you have a prediction of what we'll see happen here, Tim?
No, I think she's going to do backflips.
Backflips?
Yep, that's my guess.
You know, no one's predicted that before.
Yeah, backflips.
That's cool. All right, so...
If she does backflips, I'm going to be happy.
Okay, so we have her jog starts playing, but look what happens when she stops.
Ah.
It's actually playing, it looks like it's
She's
playing...
running into a wall or something.
Looks like she's playing a jog right? It's just kind of random. The reason for this is because the minute you stop, that direction has now hit 0. So that direction's not updating because since I stopped, I'm not actually heading in any given direction.
Right.
So,
But
that number I'm feeding in is not the number I want. What I actually want is a direction value. The minute I take my finger off run, I need to somehow like save that number and feed that into my blend space.
So
This
no
is-
backflips.
No backflips. I'm sorry.
It's okay.
Sorry. So real fast, let's go ahead and get this blend space set up. We don't want it to loop. Let's go ahead and leave this for now. So we're going to basically need a new variable. So here's something pretty cool with our state machines is, as I'm running and I stop running, I want something to happen. So right here on the side, we actually have some custom events we can make, a blueprint node. So on the left, when I left the state, so the minute I'm no longer running, I'm going to leave the state to go to jog stop. What I want to do is I want to kick off an event to happen. So
In between run and jog stop.
Yeah.
Okay.
And think of it as just when I'm not running. It's just the minute I leave that run state.
So like back to your idle state or something.
Yeah. So basically, what I want to put here is let's just say we'll call it run stop. That's a run stop event. Okay. And let's compile. Now, if I go to my event graph, this event's going to show up on my event list. So if I do event, and what do we call that? Jog, run, stop?
Run stop or jog stop?
Run stop.
Yep.
That's why naming conventions are good to follow, because I've called this jog and run, and you get really confused. But
Yeah.
yes. All right, so now we have the anim notify run stop. So the minute that fires off in my state, I can actually trigger something to happen. So what I want to happen is I want to go ahead and get that direction, the direction variable I'm always setting at any given time. Let's go ahead and get that. And I want to go ahead and create a new variable. So let's go ahead and promote to variable. And we'll call this direction on stop. Let's call it that. Direction on stop. So what that's going to do is the minute that fires off when I leave the state, it's going to tick over here and it will say, hey, set this value. What value should it be? Oh, your current direction, right as we left the state. Theoretically, this should work. Okay, let's go back to our anim graph. And so instead of direction, let's go ahead and plug in the direction on stop.
Oh, that makes sense.
And this direction is always updating every
Right.
frame. And so the minute I lay off, that direction is just going to go to 0 or something.
Right, because you no longer have a...
This is a lock steady. This is like the minute I stop, that value has been set and it's not going to change anymore.
So it's stuck in that variable.
It's going to be stuck at that number. So if it stops at a -90, it'll stay at a -90.
And now you're feeding that into your...
As I stop, because as you stop, you're not controlling your run direction.
Right.
So let's try it out. So there we go. She's playing her. Ooh.
But now she's...
So there's another bug we just saw here. That's
a
happening
sweet
right
dance
now.
move?
Yes. So here we go. So she is playing. Let's see. That is her. Looks like that's a run right stop. That looks like it's a run right stop.
Now, do you ever have a point where you're debugging and showing what animations are playing?
Yeah, actually, that's a good point. Let's do that right now because I'm obviously seeing some bugs happening here. So if you want to see what animations are playing, you have a command here that is show debug animation. So as you play, if you look to the right of the screen, it's telling me what animations are playing. So right now, if you look, she's playing her jog right stop. But if I go left, yeah, she played her, looks like she played her jog right stop. No, she played her jog left stop.
When running right.
They were wondering if it's because it was plugged into the run as opposed to the stop.
Yes, probably so. We'll go back and see. Thanks for everybody's help too, by the way. This is awesome.
It's
I wish you
teamwork,
guys
man.
were
Group
always.
debugging.
Maybe I should just stream you at my desk all day, and you guys can just help me when I get stuck. Also, while I'm on this debug, I want to show another way just to really say is sometimes the text goes by way too fast. So if you do something like slow-mo 0.3, you can play it slow, and it just leaves it on your screen for much longer. You could also use shadow. We use shadow play a lot to just record what happened, and then frame by frame.
Oh, that's really
what's
cool.
happening. So yeah, let's go back and see what I did wrong.
Can you
'cause I
speed it
obviously
up
did
from
something.
slow mo? Can you go to like
Yeah,
10?
absolutely.
So
Let's see what
it looks insane.
Slow mo 11.
Oh, you go all the way to 11.
11. So yeah,
That
you
is
know,
a Twitch
woo!
state.
And she's done. All right, that was crazy. Okay, so let's go back to what did we do? Jog combat. Was I in the wrong one? Yep. You guys are awesome. All right, so here we go. I plugged it into the wrong one. So let's go ahead and nuke this guy. And I want to point out, like, when you see devs go through this stuff and show you these tutorials online, and it looks like we just breeze through it, and it's so easy. We've trial and errored this thing a few times. It's the actual normal way to do a lot of this stuff is to plug something in, it breaks, and you try it again. So if you find you're doing that, that's standard fare. Don't worry about it.
Everybody's doing that.
That's
Yeah,
the way it's done.
it's the new thing.
The new hotness.
The new
So-
hotness.
So here we go. Jog stop, blend space. I had the wrong thing plugged in.
So you need that stop direction.
I need the direction on stop plugged in. And that should work. Sad to say, guys, I noticed something I missed on Shinbi before we went out to the public, but we actually have no logic right now. I want to cover this real fast. We have no logic between jog start and jog stop. So if you're in the middle of your jog start animation and you stop, there's no logic to get you to the jog stop and interrupt the jog start. So let's go ahead and make a quick rule real fast. I'm kind of going off on a side tangent, but it's definitely going to affect the end result of everything else I'm doing. So right now, let's go ahead and say it's going to be the same rule where if I'm not accelerating, let's go ahead and enter transition. So we'll say get is accelerating. We'll say not. And so for those of you who've, like, if you're kind of going back and forth with your runs right and left and you see that she gets stuck in this jog, that's why that's been happening. Next time we update these characters, that'll be fixed. Okay, so now we have a start. Let me go ahead and make this full screen. Okay, so she did a start, and when she stopped, she's playing the run forward stop. It's a very long animation. Like I said, we made it for our Paragon specific code. So we'll trim these up a little bit. But here she is. She's running right to a stop. It looks broken because, yeah, she should be stopping over a larger period of time. That's a stop left.
Now, would
and
you
then
trim the
here's a stop
animation
backwards. Yeah, I would
or extend her
definitely.
motion?
I would trim the animation. We have speed warping, and that's not out yet. That will find the place on our animation to play based on distance of where you stopped.
And that would continue her momentum to the left
and
or
it
right?
would keep her. It actually keeps her feet totally locked on the ground. There's no foot sliding at all. This system is not the best at solving for foot sliding. It's basically define your speed and then do your animation so there's no feet sliding. So our new systems that we're going to release later this year will solve that far easier. But for now, let's go ahead and modify our jog stops. And I'll say this, like, I know I'm saying this a lot, but please duplicate these before you create new ones. I'm not doing it here.
But we have
I
backups.
Risky
should be.
business.
I have backups, but you know, I'd hate for you guys to be lost without the original. Okay, so here's her stop backwards. As you can see, she has several steps before she actually stops. So let's find a good point for this kind of system. Let's find a good point that we would like before she stops.
Where it doesn't feel too abrupt.
Yeah, you don't want it to feel too abrupt, and you also want it to be a good blend. So usually what I look for are moments where her feet are together. So you can't tell if either leg is extended out in front or not, because you never know when she's going to jump into it. So here she's running backwards. I'm not going to spend too long on this, but let's pick about right here.
Is that assuming that the camera is behind the character then?
Yeah, always make your decisions based on what your primary gameplay camera is. Always. It's pointless to look at her from a front 3/4 view if you never see her in that. So absolutely. So let's pick about right here, frame 30. And I'm going to do that. I'm going to trim off. So we're going to say remove frame 0 to 30. And let's go ahead and do this with the forward stop. For anyone who's really knowledgeable about blend space and animation systems, I'm sure you're sitting there going, these 4 animations don't make the best blend space either, because she might be stopping on different feet. I'm trimming them at kind of different times. So I think another way you might want to do this is basically say if a value is like between these 2 numbers, go ahead and play this full animation where you're not really necessarily doing a blend like in a blend space. So here, let's go ahead and cut it at, this one seems, I'm just going to cut it here, about frame 19. Let's do jog left. This one's tough because she's kind of she does like a big step before she stops. So let's just cut it about here. I'm going to cut on frame 9. You guys feel free to try something else. You guys could probably find something even better by spending more time with it. And then here's her stop right. Stop right, she actually does a lot of small shuffles, which is, it's tough as an animator to kind of work this kind of stuff in if you're not using our Paragon specific nodes that we have. But for now, let's go ahead and let's cut it about right here. Cut on frame 9. Okay, so cutting these animations are automatically updating the blend space. I don't have to go back and edit the blend space at all. Those changes have now
It just propagates through everything?
propagated to that.
That's awesome.
Which is good. And now we can play this again, and just we'll see if the stops feel a little better. So that feels better to me.
Yeah.
Her stop forward feels great. Let's see what the stop backward feels. Yeah, it's a little, it kind of jolts a little bit, but it's not bad. Her stop right, she definitely does a foot slide. I would probably trim a few more frames off that.
Oh, that was,
Ooh,
yeah, that was
and
heavy.
then her stop left is just, that's a rough animation. Let's,
Is it hurting you inside?
oh boy. So this one's tough. Let's just try to trim a little bit more off the run left.
A little off the top.
A little off the top. Let's see what we can do. We'll do one more round of trimming, and here's one more cool thing: is you don't have, like, if you notice, I still have the game running. I still have it running in Pi. I can go ahead and trim off a little more. So let's try trimming it here again. So I'm deleting another 13 frames. That's going to propagate again as well over here. So let's see if that, yeah, that feels better. It's not perfect, but it's definitely much better than what it was. What do you think, Tim? Does that feel better? You as a non-animator.
It looks a little, her
yeah.
legs are a little too far apart, I think.
Yeah.
In that stopping. But I think it's
it's
better than it looks like she's going to fall over.
Yeah, she kind of kicks that
trips.
back leg out a little bit. And in this case, what I would do is actually take this animation back into Maya and just tweak where her
The
leg is. Because if
animation
you,
itself,
if you look at the animation,
And now with Live Link, you
yeah,
can see it real time in the engine.
yeah, and actually, do we have people kind of responding right now? If I were to ask a question, could I get a
Yeah.
few?
Yeah,
Okay.
of course.
So how many of you guys out there are using Maya versus, say, Max or Blender? Like, would it be useful to see our Maya pipeline, how to get this stuff in? We'll see what people say, because I would love to show that as well, because there's some really nice ways to modify animations on the fly from Maya. All right. So how are we on time, guys? We good?
We got a couple of Mayas, some blenders,
Okay.
Lots
a
of
lot of
blenders.
blenders,
A lot of blenders.
some Macs.
All right. I will do a. I think I'll do a one later, probably with Maya, but you can use Blender as well. It's the same kind of concept, but basically Maya or Unreal Engine has a listener. So if you update an FBX file, it'll automatically import it, upload it, and so you can continue playing your game. You could be in Pi, modify an animation in Maya or Blender, even while she's running, it'll update the run.
Yeah.
So you don't have to pop back and forth. We're really trying to cut out a lot of those button clicks that eat up your day. Okay, so let's see. Looks like we got her blend spaces covered. Oh, I did mention I want to go and show you some things in a blend space that help them work better, especially your runs. So let's go ahead and go to open up a jog animation. Here's our jog forward. And I believe I covered this on the first episode, but I want to go over it again as it relates to blend spaces. But here on the notify lines, we actually have sync markers. And so if I wanted to, let's go ahead and delete these, and I'll recreate them to show you how they're done. But what we want to do is create a marker right when her foot plants. And that way, if you're blending a run forward with a run right, it knows where in the cycle it can blend the character. This will let you have maybe a run forward with like 4 or 5 cycles in it, and maybe your run right only has 2 cycles. And this will keep them all in sync.
Does that give you another chance at error, though, because you're telling it, you're saying, hey, this is where this is actually happening?
There's always room for error when you're putting in data.
Yeah.
But without it, your syncs, you're going to get very mushy blends with your feet. So we have a pretty good rule that we tend to follow for placing these that keep it pretty locked. So what we say is right where my pointer is, that's essentially 0, 0, 0. This is her, let's go back to perspective so I can tell what leg that is. Okay. So in the very beginning of the animation, that's her left leg. So we're going to go to the orthographic view. And the rule we set for placing sync markers is when the foot bone passes that 0 plane, or actually, or it could be her root bone plane, but it should be at the 0, 0, 0. When it passes that, that's where we want to put the sync marker. So we know that's her left foot. It's right over that middle. So I'm going to right click. I'm going to say add sync marker. And the rule with these is as long as they're named the same, it'll always sync with other markers with that name. So we happen to call these left and right plants. So we'll call this left plant. And let's do the same for the right foot. So about here, it's passing that 0 plane. So let's go ahead and create another sync marker. And then again, this is a multi-cycle run cycle. So now left is here. At this point, we've created this. I can just copy and paste. So I can copy all my lefts. This kind of speeds up the process.
You just still have to get the timing right, but
Yeah, you still have
You don't
to,
have to remake
screw
the
up to
marker.
the frame, but you don't have to like click and type in. To any new developers out there, you'll find the best way to buy yourself back a lot of time is just get rid of all those mini clicks and typing. Get rid of all those, as many as you can. So we're going to do this. Control-C. I have talked to developers who didn't know about this copy-paste thing for sync markers.
Oh,
And they
really?
literally typed in hundreds of them
oh wow.
without knowing. So if I helped anyone else out there, I hope I did. So, all right, so that's what we have for sync markers. And you'll notice all our other, actually, looks like, oh, these are our stops. Let's go back to,
So any of the jogs.
yeah, all the jogs. You theoretically could put sync markers in for your stops if you have lots of foot plants.
If it's a very long stop, or
Yeah, yeah. So as you see here, we have our other sync markers already plugged in, and that's how you can get your animations to sync up for a blend space. Back in the old days, some of the older animators who've been doing games for a while, you always had to start a run cycle with like your right foot fully extended. Your project always made whatever rule it was. Your right foot has to be extended on frame 0, and you can only have 3 cycles. With sync markers, you can get rid of that. You could have phases way out of whack between different animations, and this will get them all back in sync. It's a pretty powerful way to sync things up again.
That's awesome.
So I think I covered, let me look at my notes real fast, guys. I believe I covered everything on the blend spaces and getting the strafe system. So let's go ahead and work on, this is a very simple turn in place system. There's 2 different versions. I'm doing this super cheap because it would be nice, if you guys just want to learn some basic concepts, get in a pretty simple turn in place. And then as time goes on, we could maybe do another one where you turn after you've aimed, 90 degrees first. But for this one, it's simple. It's pretty simple. Like if you're turning right, you're going to play a turn in place. So with this, let's go ahead and find there. We do have turn animations already in these libraries. And we're going to use the turn rights, the 90s, and the turn left 90s. Like I was saying earlier, it's good to duplicate these. In this case, I'm going to duplicate it because we're definitely going to chop this one up. So we'll call this turn left. I'm going to call it loop. And let's do the same with turn right. Turn right. Loop. I'm going to fix my spelling error here. Okay. And these turn animations were made for, again, some future nodes we're going to release. And so they actually have a turn in place, and they have a really long settle. That's really nice. We want these to loop, so I need to trim out this settle, because essentially what I'm going to do is build up logic that if you're aiming to the left or right, we're simply just going to play a loop in place animation over and over.
Why do you want that long settle?
The reason you want a long settle, just for animation reason, is in game you've turned yourself pretty quickly, and you naturally expect the body to overshoot and settle and get back into an idle, and especially our heavier characters. And games in the past usually cut the minute they turned, they cut, and it makes that animation feel very like light and disjointed. It feels gamey. So yeah, we added a lot of that just to hide, where players can't tell where the turn animation stopped. It just feels all very fluid. But in this case, I'm going old school. We're going to do like an old school turn system here. So let's go ahead and open up turn left loop. And I'm going to find a spot here where I feel the animation loops pretty good. So she basically finishes her turn about frame 30, seems to me. And if you guys are looking at this animation saying this doesn't look like she's turning, what it is we've countered the turn. And so when we exported the animation, she's aiming forward because we know the capsule in the game is going to turn her 90 degrees.
Oh, I was thinking of it because the cloth on her arm stopped moving.
Yeah. Yeah, so let's go to frame 30. We're just going to cut here. Remove. This time we're trimming the end. So I'm going to trim off 31 to 60. And if I play this, you'll see that it's not the most perfect blend. In fact, I actually want to take out a few more frames of this. So let's do 27 to 31. Let's play it again. All right, and this is feeling more like something that loops. The last frame and the first frame have a difference here. What you can do to smooth this out a little bit is go to Asset and add looping interpolation. And for some reason our screen flickered, but it's okay. So it's going to add an extra frame at the end of the animation to basically help it blend. So now if I go first and last frame, you don't see much of a difference.
Oh, yeah.
There's a bit of shadowing difference, but
yeah,
you're not going to notice that.
So basically it makes something that's almost loopable, it makes it more loopable. And let's go ahead and do the same thing with turn right loop. let's go ahead and trim off some
In
things.
theory, would it be the same number of frames that you'd cut?
It doesn't actually. It doesn't have to be with the system I'm doing, but generally no. I mean, it depends on what system you're using. We have done turn and play systems where we are getting a turn rate speed that's dependent on the frame numbers in your animation. So in that case, yes. In my case, all that I want is something that loops,
Gotcha.
and I'll keep playing that loop until we're not turning.
Because I think it was 27 to 60 frames the last time.
Yeah. I mean, if you can get it pretty right, close,
Then
it's
it just
probably,
feels as-
better. Yeah.
Yeah.
Okay, and again, let's go ahead and add looping interpolation.
Let's see if it does it again.
All right.
Nope.
And then, yeah, if I compare last frame to first frame, it's pretty darn close. All right, so now I have my looping turns. So let's go ahead and save these two assets I just created. All right, so now we need to add logic for turning. And let's see, let me look at my notes here, guys. All right, so let's go to the animation blueprint. And we're going to create basically a new state off the idle state. Because if I'm turning in place, I'm only going to be turning in place if I'm idling, right? I'm not going
Right.
to turn in place from a run or stop or anything else. So let's go ahead and drag off and create a new state. So we'll say add state, and let's call this turn in place. And then let's go ahead and make a rule set to get back to it. And let's go ahead and do our logic to get into turn place. Before I plug in animations, let's go ahead and think of the logic. So if I'm turning, I need to be standing still, right? So we want our speed. Speed needs to be 0. So speed, let's say, equals 0. And we also need an AND bool, because basically we need to be standing still and we need to be turning. So where we're getting our turn value is from the yaw. So let's go ahead and get what the yaw is. And so yaw needs to be greater than 0, right? Because if you're turning, but also yaw could be negative, right? It could be negative 20 degrees or positive 20 degrees. So basically,
depending on left or right.
What's that?
Depending on your turn.
Yep, exactly.
Okay.
Your yaw can be negative or positive or negative. So let's see. Let's go ahead and try it. This is going to be a case where I'm going to try it. Something will probably break, and we'll go back and modify it. So let's just go ahead and, for now, let's say yaw is greater than 0. And usually when I'm figuring out this logic, I actually don't care about what animation is going to play. I just want to see that something does play. So for now, let's just go ahead and plug in. There we go. I found it. It didn't hide that time.
No.
Let's go ahead and plug in one of our new looping animations. So we'll just do turn right here. Okay. All right, so right now we have idle, and the rule I created was is speed equal 0 and is my yaw greater than 0? If so, let's go ahead and turn in place. And we're playing turn in place loop. I'm going to have it set to loop. And right now I have a state that we can't get out of, which is fine. I'm just testing the logic real fast. That's all I'm going to do. So let's try this and see what happens. Okay, so we have Shinbi. Do you predict backflips?
Not this time. I feel
No?
like she's moved beyond that.
Okay. All right. So, okay, I got into the state. She's standing still. She's looping. I have no rules to get out of the state, so she's perpetually
stuck in that
turning
loop.
in place right now. But if I'm turning my camera, we're getting some semblance of a turn in place animation.
This dance continues.
Let's get this, and let's go ahead and stop. So I mean, our logic, I guess, is holding up.
Right, because you're in that turn state now.
I'm in the turn state,
And
so
now you just need to go back to idle.
Something went right.
Right.
Yeah, so now let's get back out of idle. So there's lots of things that can kick you out of a turn state. There is, let's say you start running. You don't need to be turning anymore. So we'll say get speed, and we'll just say your speed's greater than 0. Instead of doing an and bool, because we're not waiting for 3 things
Do
to be
an
correct at
or.
once. It's or, right?
Right.
So we'll do an or.
Because any of these things will kick her out of that state.
Yep. Any of these things can kick you out. And let's also do yaw. We'll say if yaw equals 0, you're no longer turning.
No longer turning.
So let's go ahead and get yaw. And let's what I've found is sometimes even when you let go of your mouse, your yaw will still give you like a 0.0001.
Because you may
Key.
have pushed it on the way
There
out.
might be something.
Yeah.
So for this, I found it's best to say greater than and give it something that's not 0. So say like 0.01. That just kind of it gets rid of any like micro feedback you might get from your mouse or
The dead
controller.
zone kind of stuff.
Yeah.
Yeah.
So let's try this logic now.
So if your speed is greater than 0, or your yaw is greater than 0.01.
Oh, did I say greater or did I say less than?
I think you said greater than.
See, I probably messed up. So let's see. All right, so probably what happened here. Yeah, I can't get out of it because I meant to say less than 0.1. Because essentially we want it to be. There we go. Sorry, math teacher. We animators do use math. I'm telling you. We only have to count to 360, which is cool.
That's fine, yeah.
A finite.
Finite. Maybe sometimes 720. I don't know.
They've mentioned a couple times about a not nearly equal node. Have you ever utilized that?
There is a not nearly. There probably is a good reason to use it. I've not used it because I like having that some exact number in there.
So there's not nearly enough reasons to
There's
use
not
it?
nearly enough reasons. I would like if you guys have a good use case for that. I would love to hear it because I've not used it. All right, so if you notice, something's broken here because if I go left, okay, she's going in there. If I go right, she's not. So the logic isn't quite perfect. I have messed something up, and this is normal. This is part of it. So basically, that yaw, I have less than 0, right? Remember what I said about if she's going to the left, she's in a negative range. I actually want her to still turn if her yaw is less than 0.1.
So you need an...
So what I need is an absolute. And basically what an absolute float will do is just take, whether it's negative or positive, it'll still spit out that number. So let's see if that helps things a little bit. Come on, let's see if okay. All right, so her left is working, her right isn't. And I think it's for the exact same reason. I didn't put an absolute value on my entry point. But here we have essentially a working turn left. I have now made a working turn left. I have not made a working turn right. So let's go back and try again.
And add the absolute again.
Yeah, so let's go ahead and add an absolute here.
Even though it's 0?
But it's absolute greater than 0. So, you know, like 0.1 is greater than 0. Negative 0.1 isn't, but absolute will make all things that are not 0.
Gotcha. Okay.
Yeah. All right.
Okay.
So there's left. Or sorry, I'm still playing a turn right. And if you notice, she's just playing it over and over. Something is not letting me kick out of it. This is a good case of where you do want to print your print string of what yaw is, because it could be a number of things. My logic could be broken, or maybe this mouth, you know, for whatever reason, yaw is kicking up a number. Let's just take a look and see what we have.
And so you're just going to do that print screen?
Yeah, let's go to print screen real fast. And if you guys have a really messy spaghetti graph and you want to find where a variable is set, you can right click on it on your list. And you can find your references. And it'll give you a list of your references. And right here, there's a set yaw. So this shows me where it's set. If I double click it, it'll take me to it on the graph. And here I can go ahead and do my print screen. Again, we're going to move this to the in string, and let's move the arrow through here, the executable. That looks good. All right. So if you noticed here,
would you do the slow-mo here as well?
You can do it. Actually, let's real fast. Did I? Yeah, I have duration clicked. Actually, I just want it to stay there for a while. Let's go back and do this again.
Oh, I see.
All right, so it's 0. That's fine. It's 0. All right. So see how it's like sitting there at 0.00. 0008.
Right.
My hand's off the mouse. So personally, I don't know what's causing that. This is why I was setting in these rules.
Because you're never getting to absolute 0 at this point.
Yeah, I'm never getting to 0. That might be the cause of this. So let's go through this again. So let's say yaw. So going in, I want it to be 0.
Yeah,
That's
they're
fine.
suggesting how you did the transition, how you had the like 0.01 value.
You guys are awesome, seriously.
So I think on the one on the bottom there, right?
Yeah, so it'd be this one, right? And I want it to be less than.
Well, was it?
Right.
You'd want it.
Because this is the leaving state. It wasn't leaving the state, right? First. Maybe. Am I getting close? Are they saying no?
They're just they're saying you want to stop entering, or
They're
if you
saying
can
that
use
one is
the
good.
nearly equal to.
Oh, nearly equal. Let's try it. Let's try it.
Live learning.
It's new for me. You guys are teaching me. You're
Unreal
teaching
Academy.
me some good things. So let's try it. Okay. So speed's fine. We know that.
But yeah, they were saying it's the entering state that's causing problems.
The entering state. Okay. And so we want it to
Nearly.
be.
Because I think if she's stuck at 0.01 or 0.00 whatever, then she'll keep entering, right?
Well, the yaw is continuing to move.
Anyway.
Yeah. She is. She's entering it. You're right. Actually. So greater than.
0.01.
Yeah. So let's just do point. Yeah. You guys are right. Yeah. I'll get there eventually.
Oh, yeah. Live debugging.
Eventually, these neurons like make a connection, and I get it.
Nearly there.
Nearly there. I still didn't use nearly node. I avoided that.
But you did it gracefully.
Yeah. All right, there we go. So yeah, she's getting in and out.
She told
Way
you
to
you knew
be,
what
chat.
you were
Yes, chat.
GG.
Awesome. But right now she is only playing one turn in place animation. She's playing turn right. So let's figure out how to play just a turn left. Like I said, there's more than one ways to skin a cat. I did it one way. I'll show you the way
Poor
I
cat.
did it. Real fast, I'm going to get rid of that print screen. I always recommend deleting those as soon as you possibly can, because sometimes you get used to them being there and you check it in and someone yells at you for spamming their game. So let's see what I want to do here. Let's do...
Who's Chad? Everyone's congratulating Chad.
Who is Chad?
I don't know.
It's Chad.
Hey, Chad.
He's talking to us.
Chad.
He had a question.
Okay, so let's go to the anim graph. Here is my awesome animator way to solve for which turn right or turn left to go with. Like I said, more than one ways to do this. So let's go ahead. I'm going to go ahead and get yaw again. We're using yaw for a lot of things. And let's do blend poses by bool. Let's scroll up here. Okay, so blend poses by bool. If yaw is greater than 0,
Or nearly.
or nearly, all right, if yaw is greater than 0, that means you're going to be definitely, we don't want an absolute value here, because anything greater than 0 is going to be going right, correct?
Right.
So that's our active true value. So our true value is right. So let's go ahead and feed turn right into true. And if yaw is not greater than 0, we are going to play turn left.
Somebody's saying that you deleted the print string but didn't reconnect the execution path.
Oh, thank you. Thank you. My God, seriously.
This is
I'm going to live stream me just at my desk, because I would get stuff done so much faster. Yeah, let's go back to the event graph.
Look at this.
Look at
graph.
this. And
I don't know what they were talking about. Clearly, it's reconnected.
It's reconnected. I would have, like I said, I would have got there eventually. You guys just cut off 10 minutes of the stream. Let's see, and let's go ahead and let's play, test everything. All right. So here we go. She's playing turn right, and it looks to me like she's playing turn left. Like I said, these are cut up turn animations that aren't quite what you would author for this system. Let's show debug animation. And that says turn right loop, and this is turn left loop. So I actually have my I have my rules, my logic switched, which is fine. I'll gladly take this. That's an easy problem to fix, because that is just a matter of switching two things. Although I will have to think more deeply about why. Yeah, anyway. You guys know. I know you guys know.
We understand.
I'll get there eventually.
Chad understands.
Chad, thanks, Chad. Okay, so, and there we go. Left turn, right turn. She's turning and she's strafing. Like I said, these turns are actually authored for a different kind of system with our distance curves. But this will help me segue into, I want to show how to retarget animations. Do we have time? Are we
Yeah.
good on time? Okay. I'll go over this pretty quickly. It might take about 10, 15 minutes. Okay, so Shinbi doesn't have any other turn animations for me to use if I want to use them. However, Sereth did have some that I saw that I liked. So let's open up Sereth real fast. Where is she? Shinbi. Did I not add her to my thing? Oh, here we go.
Sarah?
Yep, she's right there. Characters, heroes, Sereth, and let's look at her turn animations. The way I generally do a turn animation, like we just did with Shinbi, is there's this turn in place style of animation where it gives you more of a subtle turn. This one's super subtle, but she also has another one that's a little bit bigger of a turn in place. To me, that's a little bit too big. But just for the sake of this conversation, let's just say I want this one. Just give her a super light turn, and maybe I could play the play rate a little bit faster, as she turns. So we have this right now. I can't play this animation on Shinbi, so I just want to show you guys how you can retarget animations to different character packages. So let's go to Shinbi's. Let's see. Let's go here. All right. Let's try this. She might not have her rig set up in place. I'll go over that. So she has her turn in place, and let's say I want to go ahead and retarget it. Go back up to the retarget anim assets. This is what we used last time I did a stream, but we did it to retarget a blueprint. This is for a specific animation. So right now I want to retarget her, but Shinbi is not on this list of characters to be targeted. I could get her on the list by simply clicking allow remapping, only show compatible skeletons, and she'll pop up. I actually want to show you guys how to make a compatible skeleton. So let's go to Shinbi, and let's go to her mesh file, her skeleton file, I mean. And you should see a retarget manager panel. If it's not down here, you can turn it on up here at the window, and there's a retarget manager. So we have a concept in here, and it's called a rig. And it's not like a rig you would have in Maya or Blender or Max. It's not like a control animation rig. It's basically a list of bones and what those bones should map to on another character. So in this case, we have some set up already. We've shipped out a Paragon Proto Retarget, or sorry, Orion Proto Retarget. So let's click on that. I'm going to go ahead and save her skeleton. And this window is cutting out a bit of what you should be able to see. Let me see if I can somehow, let me see if I could resize this window. It looks like it's not letting me resize this, so we should probably put in a bug for this. But right here, if you guys can see it on your computers, you can scroll through, and basically you can see what we're mapping bones to. So in this case, a root bone will map to a root bone, pelvis to pelvis. For our models, they all have the exact same bone name, so this is super easy. But if you're retargeting your own stuff from, say, a different skeleton source, this is where you do want to map the bone names to their respective bone. And then in this case, most of our characters have what we call an A pose. And this is basically, this can be her retarget pose. So right here, if I click view pose, that's going to be her retarget pose. In this case, that's the exact same pose as her, what we call like a bind pose. So I can modify this pose. Let's say one of our characters is in a T pose and not an A pose. I can go to modify pose. I could say use current pose. And so let's say right now, like I said, if I hit view pose, as long as this says hide pose on it, we're looking at her retarget pose. So let's try to get her arms in a T pose. Let's say upper arm R. Sometimes you see characters come in like this, and that would be her target pose. If I go to retarget manager, I can modify pose and say use current pose. Now if I hide pose, we're going to see her bind pose. That's just how she is in the editor. But if we want to look at her retarget pose, that is now saved right here. And if all our characters across the board have this exact same pose, their animations are going to retarget with each other much better.
Because it's looking for that exact.
It's basically going to maintain what it does. It looks at two different skeletons, and it assumes they're in the exact same pose, and then that way it'll transfer like the rotations and stuff,
So basically
in a relative position.
interposes them.
But in this case, we actually, between Sereth and her, they're both at that, what we call a pose. So I'm going to go ahead and just hit reset. And now her pose is back to what it was, which is what we want in this case. Okay, so we do have her rig. So let's go ahead and save the skeleton. Now let's go back to Sereth and try this retarget again. Turn in place 0, and let's go to retarget, duplicate. Now you'll see that I have a compatible skeleton over here.
Because it's both
to
in the
map to.
pose.
No, it's not because they're both in the A pose. It's because Sereth is looking for another character that has a rig assigned to it. As long as they all share that point to that same rig, the rig asset, they are compatible.
Gotcha.
Animation-wise.
That makes sense.
And real fast, I'll show you guys where the rigs live. Should be under meshes, and you'll see the rig file. Not to go off on too much of a tangent, we have given you rig files that are the definition of what a Paragon character skeleton hierarchy is. But let's say you have your own skeleton hierarchy and you want to create a new rig. All you do is you simply right click on the skeleton and you create your rig file right here.
And it creates a rig based on
And it'll create
bone.
basically your bone definitions.
Gotcha.
Sorry, I don't want to get this too complicated for everybody. But right now we have Shinbi skeleton. They're both in the A pose. And I want to go ahead and point to where I want this new animation to go to. So I'm taking a Sereth animation, I'm putting it on Shinbi. So let's go ahead and drop this new animation into her animations folder. And I'll keep the same name, totally fine. I think it's called like turn. What just happened? I think an autosave just kicked me off. Let's see, let's try it again. Huh. We'll try this again. Looks like an autosave kicked me back. Let's see. Turn in place 0. Target, duplicate. Should be characters. Okay, I have this set up, name's the same, and we'll go ahead and hit retarget. So now we do have a turn in 0 retarget animation in the Shinbi animation folder. Now, you can see she's playing that same animation that Sereth was playing. Now, if you get on closer inspection of the animation, you can see like, looks like she has like clown shoes on. Her fingers are probably gonna be messed up. Yep, her fingers are messed up. Her hips are actually kind of moved. This is because we're actually taking translation data as well from Sereth onto her. We only want rotation data. So think of each joint, right? Or fingers, right? Sereth finger joints are in different locations than hers, and it's being literal. It's not being smart.
Literally
about
going, here's this, put it here.
But we do know that we do want their finger rotations to be the same. So to fix this, is you want to modify the skeleton of your character to be able to take retargeted data. So let's go to her skeleton tree, and you can do this on the animation panel. You go over to the skeleton tree, and under options, show retargeting options. And right now, see, you get this translation retarget column. And basically this is saying where are you going to get your translation data for all your joints. Right now it's saying it's coming from animation. Your other options are skeleton, which basically that's saying translation in basically the rig pose. You know, this bone's always going to be the same offset from that bone. That's one way to get your translation retargeting. And we have a couple other options that I'm not going to go into right now. But in this case, we want skeleton for like the fingers. We only want rotation data on them. I could go in and click on all these one by one and change them to skeleton, or I can go to basically the top parent, which in this case it's going to be pelvis. I can right click and I can say recursively set translate retargeting bone to skeleton. And now if you notice, everything looks good, right? Her fingers are, maybe some of the rotations are off a little bit because our rig pose, you know, we didn't go in and perfect the rotation of the fingers, but at least they're not all jaggy. Her feet look good. But if you notice now, her hips aren't moving, right? Because I set it to skeleton. So for pelvis, let's go ahead and turn it back to animation.
Specifically for pelvis.
Just for pelvis. And so now she has basically her own little kind of mini turn animation. And so I'm going to wrap this up pretty close. I want to leave some time for questions. Real fast, I just want to see what this animation looks like in her turn right and turn left. So let's do, what do we call this one? Turn in place 0. And let's go ahead and do this one. I'm going to go ahead and play the next one backwards. So play rate, if I do -1, it'll play the animation backwards. So really, you know, if one's turning right, the other one's going to be playing backwards to go left. What'd you call it earlier? Not a hack. It's a unique
workaround.
A unique workaround.
A unique approach.
Let's do a unique approach. I like that. And who knows, this may or may not work. This actually doesn't work because her entire pose is so insanely different. Probably what I would do is make maybe an additive on her feet. Yeah.
To bring her right foot in some.
Yeah. In fact, I probably wouldn't use this at all. Consider this an experiment that didn't quite work. But anyway, I want to show you guys how to retarget animations.
That's all right. That was awesome.
Let's go ahead and leave it for some questions right now.
All right. So they're wondering if you could really quickly, you sort of walked through some of the sync markers, but didn't show it in action.
Oh yeah, sync markers in action are basically it's like plug and play. So if I go, let's open up a blend space. Let's go to Shinbi's blend space here. So right now, her feet are always in sync, whether she's going forward or sideways or backwards, because those sync markers are plugged in at the same thing. So probably the best way to show this is maybe remove sync markers and show you what happens. Let's load up the jog real fast. I mean, it's pretty simple. I mean, the way it works is that it's always going to sync the animation. So it won't just start the animation on frame 0. Let's say we're playing a run forward and the right plant is on the run forward. It's going to go ahead and enter this animation at this frame, on the right plant. It's always going to keep them in sync. And in fact, if your run forward animation is 15 frames long and your run right animation is say 30, it'll scale the run right animation to be in the same phase based on these. So these are essentially plug and play. They're pretty much invisible after you've plugged these in. They just work.
Oh, okay.
Yeah.
They were commenting that it looked like these animations had lost the lean angle.
Yes. They absolutely did lose the lean angle. There's 2 ways to solve that. I kind of ran out of time for today to go over that. So one option is, right now I have a 1-dimension blend space. I could go ahead and make a 2D and add the leans back in.
Mm-hmm.
The other option is, the reason I want to save this is I want to go over additive animations next time I do this. The other option is to create actual additive poses, and that's what I plan on doing here. And basically, based on yaw delta, we'll just play a lean right or lean left additive that will play on top of a blend space.
Okay.
So I'll cover that next time. It's a good
So
question.
Part 3.
Yeah, part 3.
Let's see. I think we had briefly talked about explaining the Shinbi the locomotion state and the transition between the jog, stop, and idle, and why are there 2 transition rules?
Yeah, actually, I saw this question. You read me this question earlier, and I peeked in. There is definitely some redundancy here. We set is accelerating, if speed is greater than 0. I don't know if this was like me, like left this in an experimental state when I did it, but honestly, you don't need both of these. So just case in point, I can go here, disconnect is accelerating. I can go ahead and remove the pin. And if I were to play this, if I were to play this, I believe she'll run just fine. Yeah, she'll run just fine. So that's just redundancy on my part. That actually didn't need to be there.
Okay. They're wondering, seems to be some issues with her like hair flipping. Is that part of the animation, or is that part of?
No, that is, so her hair flipping when you play is actually motion blur, screen space motion blur.
Mm-hmm.
That's just a problem. That's just a motion blur. It's a motion blur issue. Skeletal meshes and motion blur are a little bit off kilter.
Mm-hmm.
I believe one way to fix that is you can go. Let me see if I can remember this correctly. I believe I can go to her. Oh, you can go to your project setting and turn off motion blur.
Mm-hmm.
Or you could put like a volume, I believe like some volume control on her actual blueprint that will turn off motion blur.
Cool. How can you blend between the different movement modes like forward-facing and strafe style motion setups in-game?
How could you actually, how could you use both if you wanted to?
That's talking about a blend between the different modes, like forward-facing and strafe.
You absolutely can do that. We did it like way back in Gears of War. You know, Roadie Run was just a forward-facing motion.
Mm-hmm.
When we did Paragon, our travel mode was only a forward-facing. So honestly, I would probably just do a different state.
Gotcha.
And don't put a blend space in that state. Oh, I know what you're saying. Also, orient towards camera or orient towards movement, because that is like that's a setting that's not dynamic. So I think either way, you're gonna have to put in some math to solve for orient towards movement.
More math.
More math. Get a programmer.
Nearly.
Get a
zero.
programmer. They're wondering, is the setup for all of these characters generally the same? He felt that Chimera's setup seemed a little more unorthodox than others. Do you know offhand?
It's very possible that Chimera is one of our earlier heroes that didn't use our new node system. So Chimera actually probably used more methods that we're using with Shinbi right now than our like more modern stuff. But yeah, he's definitely one of our older heroes and probably has some stuff that's a little bit different.
Gotcha.
Yeah.
Okay. All right. Well, I think we're going to wrap it up there, folks. Thank you so much for joining us, Jay. And they've all noted how you've committed to a part 3.
Yep. Yeah. No, I do. Part 3, I'm going to go over additives. I'm really hoping to show off the melee twist. In fact, I'm going to go ahead. Let's go ahead and say it. I will show you melee twist and additives.
Will you show us you doing the melee twist first?
Sounds
And
like
then we
a
can animate that
dance.
melee twist?
Yes. I'll show you melee twist.
All right.
An additive.
Dance moves with Jay.
And then honestly, keep the questions coming because there's other things that I might not think to show, and then based on what you guys give feedback on, I'll show some other things.
So all of those are good points. So I've dropped a survey in the chat. Do fill it out. Let us know how we're doing here, what topics you'd like to see in the future, or if there are specific things that you're curious about in regards to animation that can help inform Jay's presentation and for the next stream. Yep. So do fill that out. As always, check on for your local area UE4 meetups, meetup.com/pro/Unreal Engine. We'll get you there. You'll see we have groups all over the world, so hopefully there's one near you. If not, you can always start your own. And again, submit your projects to the NVIDIA Edge program. We love seeing what you're working on, and we'd love to send some sweet hardware your way. So thank you all again, and we'll see you next week.
Take care. Yeah.
Bye.
Bye.